This is a train that was invented in England over 200 years ago. A rope is attached to the front of the carriages, which are then pulled forward by a steam engine alongside the tracks. For over 50 kilometers, a steam engine is laid every kilometer. If one of them fails, the whole train stops. So the engineers modified the steam engines and put them at the front of the train. To increase the power, he added 25 metal pipes to the steam engine. When the coal in the boiler ignited, the hot air would pass through the metal tubes and heat the water in the front of the train to create steam. And then a piston turns the wheels that kept the train moving and increase its speed to 46 kilometers per hour. It became the fastest form of transportation in the world. But that wasn't fast enough. The engineer realized that the front of the train was affected by air resistance, so he streamlined the front of the train and installed rectangular plates underneath to prevent the wheels from being affected by airflow, and rubber plates were fitted to all the joints between the cars to reduce air turbulence. This aerodynamic train increased its speed to 145 kilometers per hour. Because of the speed, the wheels were out of balance, causing the train to move from side to side like a snake, making it vulnerable to derailment. The wheels had to be redesigned. Ordinary wheels like these can easily go off the track. Replacing them with conical wheels worked surprisingly well. The train was stable, but power supply was the next problem. So the engineers installed a pantograph at the front of the train. It would transmit power from the dangling wires to the train. But the high speed of the train caused friction between the pantograph and the wires, causing damage. So the engineers alternated the wires so that the friction between the pantograph and the wires was even. But an exposed pantograph can easily catch on the wires if it's damaged. So the engineers installed a compressed air wall on the pantograph. If the pantograph is damaged, the air inside escapes and the pantograph retracts quickly. When a train has electricity, it's time to set up a safety system. Conventional train signals are impossible to read in extreme weather. Plus, the metal bars inside the tracks are covered in snow and ice and can't sense them. The metal brushes under the train won't alert the driver to stop. It's very easy to have a collision. The upgraded track has transmitters at regular intervals. That transmits a signal to the cab of the train. And when the alarm goes off, the system automatically stops the train. If there's a sudden obstacle on the tracks, and it's too late to brake, the cars can collide and derail the train. So the engineers installed a bogie between the cars. It keeps the cars flowing straight down the tracks after a collision and ensures the safety of the passengers inside. And so the perfect train was built.